Hello friends, welcome back to my next video. In my last video, I demonstrated importance of p-value by giving an example of linear regression model using Excel. In this video, I would like to talk about two types of error, type 1 error and type 2 error. Type 1 error means the incorrect rejection of a true null hypothesis. That means we have some true null hypothesis and we're still incorrectly rejecting it. Type 2 error means incorrectly retaining a false null hypothesis. In column A, I have some data for independent variable x, and in column B, for dependent variable y. Just like I showed you in my last video, I have a linear regression model, and you can get this linear regression model using the scatter plot. What you have to do is go into scatter, choose the scatter plot, and there you have it. Once you right click on it, sorry, once you click on the data, you add trend line, want to display the equation and the R-square value. As you can see, the slope is 50.534 and the intercept is negative 15.105. The descriptive statistic stat that I have output in here work with this. Now, by dividing the coefficient with standard deviation, t-stat value can be calculated. So just like here, I have calculated a t-stat value. So what I did is I took the intercept, the coefficient associated with an intercept, and divided by the standard error here. T-stat value associated with the slope, which is negative 0.054. Similarly, you can also calculate the t-stat value associated with the slope. Now, based on the t-dist function in an Excel, you can calculate the p-value. The t-dist function takes three arguments. The first argument is the t-stat value. The second argument is the degree of freedom. The degree of freedom here is 18. We have 20 samples. So we have 20 samples. As you can see, we have 20 samples, and we are using this data to determine two unknowns, one slope and one intercept. Therefore, we are losing 2 degrees of freedom. If we had two predictors, in that case, we would lose 3 degrees of freedom. 2 for the slopes and 1 for an intercept. So 3 degrees of freedom. But in here, we are only losing 2 degrees of freedom. Therefore, we have 18 degrees of freedom. The third argument is the type of test. This is a two-tailed test because we need to consider both positive and the negative signature of the coefficient. In here, our coefficient is negative for the intercept and positive for the slope. Our threshold is 0.05. This is the probability. The null hypothesis is that our intercept and slope are both equal to 0. As you can see, I have already put that in for you for your convenience. Since the p-value associated with our intercept, so let's see the p-value. This is the p-value which is associated with our intercept, which is 0.9571. Since the p-value associated with our intercept is greater than our threshold value, which is 0.05, we can conclude that our intercept is equal to 0. Alternatively, p-value associated with slope is smaller than the set threshold. So there is statistically significant relationship between the x and the y, which is you can see here. So our p-value associated with the slope is 0.042, which is smaller than 0.05. So we can say that we can reject the null hypothesis and say that there is a statistically significant relationship between the x and the y variable. Now let's try change the probability associated with the intercept into numbers. But before we do that, let me remind you of what the type 1 error is. Type 1 error occurs when we incorrectly reject the true null hypothesis. Okay, so now back to the p-value. We are going to change this probability into a number. If we were to change this probability into a number, then we will have to suppose that we have 100 instances, and 95 times out of 100 we correctly accept the null hypothesis for intercept. But 5 times, or you can say it 4 times, because you have to take uh, whatever is left over out of the 95, and since this is 95.71, you can round it up and you can say 96. So that is why I have 4 instances remaining. So 4 times out of 100 we incorrectly reject true null hypothesis. This is why we introduce type 1 error. Type 2 error occurs when we incorrectly retain a false null hypothesis. And this is what is happening in for our slope. Let's change the probability associated with the slope into numbers. So again, if we have 100 instances, 96 times out of 100 we correctly reject the null hypothesis for the slope. But 4 times, the remaining 4 times out of 100, we incorrectly accept alternative null hypothesis. That means even though our hypothesis, we are rejecting our null hypothesis, but 4 times we should have actually accepted the null hypothesis. This way we introduce a type 2 error. I want to clarify that type 1 error is only introduced when p-value is greater than the set threshold of 0.05 in our case. And type 2 error is only introduced when p-value is smaller than the set threshold. For more related videos, please like and subscribe to this channel, and bye.